What's up, guys? So we have a current that is going down, and we have a loop beside it, and it's 1 centimeter by 4 centimeter, and the distance from the current and the loop, rectangular loop, is 1 centimeter. So here, the example that they gave us is we have to use the flux point of the area multiplied by the magnetic field, and then we can integrate this formula. So just to take out the information that we have, the area of the loop is 1 centimeter by 4 centimeter. The current is 1 centimeter, is 1 amp, and the distance between the current and the loop is 1 centimeter. So here, you guys, I'm going to show you an easy way to do this stuff. What I did a kind of a graphic like this, and I did the loop on the x-axis. So we have to take a part of a small area, and we're gonna call it the x, and the space between, let's say this is the current here that it's going down in this side, and the distance is, let's say, let's go with the example with the it could be any kind of alphabet letter, so it doesn't matter, but we're gonna use C as the distance between the current and the loop, and let's say A between the beginning of the loop to the distance of the point of the x that we're trying to measure, let's say this side here. So what we're going to do, we're going to use the formula of the flux, the point on the flux, and this is going to be equal to the sum from C and the C plus A of the magnetic field multiplied by the area, the point area. You guys know that the magnetic field is a constant, so we're going to take out from this sum, from the sum of the area that we're supposed to calculate to find out the magnetic field, and then we're going to do the integral of C plus A and the C. So what's left is of the area, derivative of the area. So here we know that the flux is equal constant 0 multiplied by the current multiplied by the length multiplied by dx divided by, well, actually we're going to divide by 2px multiplied by C plus A and C. So the magnetic flux is going to be equal to constant I L integrate divided by 2 pi integrate C plus A minus integration of A, of C, actually, not A. Okay, and then the magnetic flux is equal to constant multiplied by the current multiplied by the length divided by 2 pi integration C plus A divided by C. So this is the formula that we're going to use for this integration. B, they are asking, well, actually, what is the magnetic flux? So right now we can just enter the information. The constant 0, current 1 amp, length is 4, actually it's 0.04. Hold on, let me do it again. Delete. Okay, let's do it again. So this is the formula we're going to use. Constant multiplied by 1 amp multiplied by 0.04 of the length meter divided by 2 pi integration C. C, that's the distance between the current and the edge of the beginning of the loop, and that's 0.01 plus A. A actually is the whole distance here. This is the distance, actually. So it's going to be the same thing, 0.01 divided by 0.01. The magnetic flux is going to be equal to 5 power of -9 Web.